Ladies and gentlemen, good evening. Tonight we're going to talk about threads, and it is actually not difficult when you know how they work. First of all, what is a thread? A thread is actually something that can run simultaneously with your main thread. So you have a main thread where your Java program usually running, then you can spin up multiple other threads, which can actually do some heavy computation, some work in parallel with your main Java program. And so let us try to see some example of this and how we can actually control and wait for these threads to complete, because sometimes we would actually like the threads to be completed before we can actually continue our program. But first of all, a little bit of theory. Let me just press this button right here. A thread can have 5 states. First of all, when we create our threads, then it's in a new state, and that's the only state where we can actually call the start method on it. And what actually happens when we call the start method, it will actually go to the runnable state. It does not mean that it will not run right away, because there's something called the thread scheduler, the JVM thread scheduler, that will decide when that it's time to run this thread, and also on which core, the CPU core that this thread should be run on. It might be run on the same, it might be run on another one. So when it goes to runnable, then it's still not running. Then at some point the scheduler, the thread scheduler, in the JVM decides now it's time to actually process this thread, and then the thread changes state to running instead, and then the code inside the thread is actually executed. And then multiple things can happen. We can actually end up in a block state, and I will show an example of this with code in just a minute. Or we will end up in a terminated state. That is, if the code is done running, the code inside the thread, if that reaches the end, then it ends up in a terminated state. And another thing is that you can only start one thread once, or else you will get an exception. I have an example of this also. If your thread is blocked, then it might be because you are using a lock on an object, and maybe another thread has that lock on the object. So when the other thread hopefully is done with its processing and then releases the lock on the object, on the same object between those threads, then the lock is released, so to say, and then the thread can actually go back to the runnable state, and then the thread scheduler at some point again says, okay, now it's your turn to continue your work because you're not done yet, and then it goes to the running state once again. And then at some point it ends up in the terminated state in the bottom right here. That is the theory. A little bit more theory is that a thread uses a runnable. It actually implements the interface runnable, which only takes one method, which is called run. So it's a very simple interface that we need to implement. So let us just look at a simple example right here. I've created this project just to show you that by pressing File. I'm using utility and the new project like this. And just because I like the Spring framework, then I chose the Spring initializer up here. And I'm using JDK 15, new latest and greatest from the Zulu distribution. Then I'm using Gradle, and I ticked off Java version 15 right here. Then I press next. I'm using Lombok just because it gives me a lot of codes, and it just gives me a lot of boilerplate codes. And then I also added the Spring Web. We are not going to use that at all, so it was just if I needed it somehow, then it was nice to have. So, and then I pressed next, finish, and then I ended up with this project right here. Let us try to look at the first example that we have right here. So I have created this code right here, and these are all unit tests. This is how I run all of these examples. I run them in the test source folder. I'm using a spaceship at some point, and that is in the space folder right there, in the space package right here, and it has 3 It has 3 member variables, model, captain, and fuel. And I've annotated with some Lombok annotations, so I don't need to create getters, setters, all args constructors, no args constructor. That is all done for me, so I don't need to waste time on that. Okay, so let us try to create a new thread. First of all, the way you create a test, if you don't know that, is that you actually just write add test, and you can actually see that this is JUnit 5 because it has Jupiter in the package name. That Jupiter is the 5th planet in the solar system, and that's why they have named it Jupiter inside the package. So you just annotate your method with test, and you can call your test method whatever you want to. And here I am creating my thread. Look right here, thread, and then equals to new thread. And then I need to give it an implementation of runnable. And runnable is an interface. That is interface. That's the one that will contain the implementation we create. That will actually contain the code that should be run when a thread goes to running state. And this is the method that we want to override and put some code in the run method right here. And it does not return anything. So it's a simple interface, and that also means that we could actually have created as a lambda instead, because a lambda is just an implementation of an interface with one method. But we will do that. We will start up slowly. So first we are creating an anonymous implementation of runnable. That's what we do here. New runnable right here, and then we override the run method right here. And then I just create a loop where I'm placing a sleep. Sleep means wait in the current thread, delay everything in the current thread with the number of milliseconds we write here, and that is 100 milliseconds right now, just so we can actually see what's going on. And then what are we doing in this loop right here? We are just writing, I'm counting, and then then the number where we are in the for loop. Then we start the thread down here, and then we print out that after the thread has been set to start. So that means that this line here will actually be written right away, because the thread is not going to go to running to be runnable before the thread scheduler actually says that it should run. So that means first we will see this code right here, and then I'm waiting for the thread to be done. And the reason why I'm doing this is because if I just let the code run out here, then my main thread would stop, and then all the child threads would also stop. So that means that if my main thread right here would stop, then this thread or up here will also not complete its run. And then after we see this line in the console, then we will actually start seeing this code being printed out. But let us try to run the program right here, and let us try to see what actually happens. So I'll run it now. Here you can actually see it. Now we're counting, and we're counting all the way up to 100. Yes, and then the thread test ends. That's when we reach on to this line right here. So let me just go up to the beginning right here. Here we can see it after thread has been set to start, and then at some point, then the thread scheduler actually starts the thread that we have right here. So very cool. We have actually already created our first example with threads. What would happen if we start the thread twice? Let us just try that. So here I call start twice. Let us just see what kind of exception that we get, because I've already spoiled it and said that we get an exception. So let us just see what kind of exception we will get. A legal thread state exception, because we are not in the correct state. We are not in the correct state. We are not in the new state anymore. Now we are in the runnable state, so we cannot call start again. Cool. So it actually made sense that we learned some theory before we started on this code example. Very nice. Let us see what else we can do right here. So what about synchronized? Let's say that we have two threads. Let's say that we have two threads where we would actually like to, which both would actually like to fuel up a spaceship. Okay, first we try unsynchronized. This is just, we have two threads. One of them simulates a robot that would like to fuel up our spaceship, and the other one simulates a robot that's like to steal fuel from the robot, for some reason. So, and what I've done right here is that I've actually taken, here I've created an add fuel thread. You can see I can create a new thread like this by extending the thread, because the thread actually already implements runnable right here. So that means that I can actually take the threads and then extend it, and then I can override the run method right here, as I've done right here. So that's another way of actually creating you can actually create a class that extends threads, the thread, and then you can actually place a lot of stuff inside your thread. In this situation, I have placed a spaceship, and I've also created a default constructor right here. So I take a spaceship as an argument in my default constructor. And then I run my code right here, and then I take my spaceship, and then I set the fuel to the fuel plus 1. And I do that 70 times, so that means that I add 70% of fuel to the spaceship. Yeah, there's no check for the spaceship to be overfilled or anything like that. That's acceptable in this situation right here. And then we print out what kind of how much fuel do we have left in the spaceship, or how much fuel is in the spaceship, because we have a good to string method on the spaceship because we're using lombok, and we had add data on top of it. Then we sleep 100 milliseconds. We have this interrupted exception. We always need to, when we try to sleep, then we always need to catch an interrupted exception, because the sleep can actually be interrupted. I'll not go deeper into that right here. Then we have remove fuel, also extends a thread. And then we have, it takes a spaceship like this. And here we have remove fuel. This is the default constructor. It looks a lot like the other thread. The code right here, it does exactly the same, except for it actually subtracts 1. And we have, we subtract 40 in total. So that means we remove 40% of fuel from the spaceship. And here we try the thread. So first we create one spaceship right here. Then we create a new thread, add fuel right here. And then we create a remove fuel right here. And then we create a start. Then we start them. We start the add fuel and we remove fuel right here. And then we wait for both of them to actually complete. So this is there's no synchronization. They're just trying to steal fuel and put in and add fuel at the same time. So this is unsynchronized. And the reason why I show this is just because I want to show the difference when I show you the synchronized instead. Yeah, we're adding fuel. So first we can actually see we're removing some fuel, so then the fuel 2, then we're adding fuel 3. So they are actually struggling, those robots are struggling to add and remove fuel on the spaceship. We don't want that. We want, because it's not possible to do this actually, because the spaceship, it only has one entry for fuel. So we have to only access it, only one robot can actually access this spaceship at a time. So they need to wait for each other, and that is where synchronized, the synchronized keyword comes in, because we can actually place a lock on the spaceship, and then we can actually say that the one that has the lock, that is the one that is actually allowed to do stuff on the spaceship. So here in both of the threads, here we have a remove fuel, then we have a synchronized ship. So that means that we want to acquire a lock on the spaceship. If it's not there, or if it's already taken, then this code will not be called. We will just wait here. It will be called, but we will just wait here until the lock to be released. And then at some point when it's released, then this code starts running right here. And the same with the add fuel right here. So we have synchronized spaceship right here. That means that we obtain a lock on the ship. And because it's the same reference to the same spaceship, then they will actually wait for each other right here. Let's see how it actually goes this time. Again, it's the same code. We create 2 new threads. We start them both, and then we wait for them to finish. This means wait for the threads to finish right here. Run. Yes, let's see what happens now. First, we had the add fuel that added fuel, and now we have the remove fuel bot. So we start with actually adding fuel to the spaceship, and then we remove some fuel afterwards. So this is the synchronized approach. Very, very cool. There are some minor things I want to show you. We can actually name our threads if you want to. It's the same code as before, but this time I'm setting a name right here. And then I'm starting the threads, and then I can actually, then I can get the name later on. And we can also print. You can also print out the state as we talked. So so we can actually also print out the state. So let us just do that just for fun. Sometimes it's good for debugging to name the threads. Oh, that was that the code? Let us just try again right here. So there's naming. We'll just wait for it to complete. So that runs again. And here we have, here you can actually see here fuel spaceships. Yeah, so this is the fuel spaceship. So that's the robot that wants to fuel up the spaceship. It has a state of runnable, while the other one is blocked because it does not have the lock on the spaceship. The fuel spaceship, the fuel spaceship thread, it has the lock on the object. So that means that the remove fuel is actually blocked right here. It is standing here and waiting. When it's my turn, I'm synchronized on the ship. The lock is already taken. Please release it. And then at some point it's released. The lock is released, and then the remove fuel thread then runs. There's something called priority I also want to show you. The cool thing about priority is that you cannot be sure that it means anything at all. So that's a cool thing. But you can kind of say that if you want to say that the add fuel should have the minimum priority, the remove fuel should have maximum priority, then you can do that. You can give a priority from 1 to 10. So this max priority here is 10, and the minimum priority right here is 1. Of course, it might mean something if they're doing heavier work than we actually are doing here. Then the thread scheduler will try to will try to run the one with maximum priority, or will try to give it higher priority. But you cannot be sure of anything. As you see here right now, actually, then you would actually see that the add fuel will still run first, but it's also because it's synchronized. So it will actually obtain the lock first. And then it doesn't matter which priority we have when there's a lock also. So yeah. But there is something called priority. I want to show you this shutdown hook also. You can use the threads to do some cleaning up just before the runtime actually shuts down. And you can do that by calling runtime.get runtime and then add shutdown hook. And then you can create your own threads. And here we're actually using a lambda because it actually takes a runnable and an implementation of runnable. And this is exactly what this is, a lambda right here. There's no arguments to the runnables. So this one is blank. And then you just have the code right here. The JVM is about to shut down, do some stuff. We could clean up something, sweep the floor. And then we leave 4 seconds right here, so we can just it's just so we can have time to look at the console before it ends. So hook has been set. Yes, thank you very much. And then we try to end the program. The thread test ends, so that is actually this line right here, right? And then, because now the JVM is actually shutting down, then we then we call whatever is on the hook for when the shutdown happens, and that was exactly the thread that we have right here. So awesome, it works. So that's a good way to actually do stuff before before shutting down. Then we have the deadlock scenario. This is a very annoying scenario, and this is one that can take a lot of debugging. In this situation, we have now we have added a primary spaceship and a secondary spaceship to each of the threads. So it's still a add fuel thread and it's still remove fuel thread, but now they have two spaceships, a primary and a secondary one. And the add fuel wants to add fuel both to the primary and to the secondary one, but it wants to do it one at a time. So first we synchronize with the primary ship, and then we start filling this one up. Then inside the synchronized block, look, inside the synchronized block, we're not releasing the lock yet, but maybe we should. Of course, if we did that, then I could not show this the deadlock example. So, but now we are not releasing any lock for the primary ship, but we are obtaining the lock on the secondary ship instead. So that means we actually have locks. We actually want to have the lock on the secondary ship. But what would happen if remove fuel does the exact opposite? So it actually starts with synchronized secondary ship. That means that it steals the lock there. Then it starts removing all of the fuel from the secondary ship, and then it starts. Then it wants the lock on the primary ship, but that is not available anymore because the other thread has that lock right now. So it never continues from here, and the first thread will never go to. It would never come into this section right here because the secondary ship is also locked. It was the lock on the object was actually taken right here, right? This is called a deadlock. So we have two threads that actually wait for objects that are locked by each other. And it can be quite annoying to debug. And here we have the code. I'm creating a secondary spaceship, Mike. Primary spaceship is, we have a captain who's named Susan. And then I create the two threads, and then I start them up, and we wait for them to continue to complete, which they will never do. And the way that looks, it looks good in the beginning. Our code is running. Everybody's happy. Yeah, it works. Just go home, and everything is in perfect state, right? We have some good logging right here. But what happens now? Nothing happens because now we have a deadlock. And of course, you could debug. The debug is actually okay, quite good. And you could also add logging to solve the problem. But right now, this program will never end. It just runs forever right here. So that's a deadlock. And the way to solve it is, of course, not to lock each other's object like that. So, yeah. Let me just see. I think that was actually it. Yeah, no, that's one more thing. If for some reason you create a thread, but you want to run it in the current threads, if you want to run the code in the current thread, then you can actually call run. And this is actually a beginner's mistake. Instead of calling start, then they actually call run. And what happens when they call run? Then it just run the code as if it was actually being placed right here. So it's the same code as usual. It's counting up to 50 or 100. Sorry. And you can actually see what is the difference in the console, you might ask. That is actually that you can see that this line right here, it's placed in the bottom instead of placed in the beginning, after the thread has been set to run. So this is here, and this is a beginner's mistake. So usually you actually also get a warning. You can see right here. You should probably be replaced by start. Yeah, I've also done that. So. Thank you very much for watching. Have a great evening. Hope to see you again soon. Bye-bye.